Today we are working on a task that you see here. It says Julia had some Barbies. Her dog ate 7 of them. Now Julia has 5 Barbies left. How many Barbies did Julia have to begin with? First, we started with a concrete representation of the problem, like this video here. Then we connected that idea with how this person drew it and asked the students what's the same and what's different. We also connected it to this one, what's the same, what's different. Where did these 7 red counters come from? What do they represent? What about the 5? How many are there altogether? What equations can you write? And then we moved on to this one, which actually later became this one. We noticed that some people were using addition and subtraction to help them, which is my goal here, for them to learn that the one can help with the other and that there's a relationship between the two. Another student solved it this way. We also moved on to a representational idea here. Someone's using the tape diagram at the top where they have 12 altogether. That shows how many Julia had to start with, and the 7 Barbies the dog ate and the 5 they had left, showing that you can use a part-whole idea in the tape diagram to show subtraction as well as addition. And then if you look at this one, they used the Equibeam and recorded a lot of thinking on their desk. All the time we're asking kids, what's the same between this one and this one? What's the same? What's different? What's the same? What's different? These connections will help them have a deeper understanding of the math. Another one we had them take a look at was this one. There's a lot of different things going on here. We have the tape diagram here, or not tape diagram, sorry, the number bond here, and lots of equations, part-whole mats, counters. There's a lot going on here. We also have, someone else did this one, and I play the fool and ask, why is there n in a math equation? And the kids are able to tell me that n just stands for the missing number, that's all. It's just holding a place as if there was a box there. And then we start to notice this. Kids are starting to notice the same numbers over and over. 5 plus 7 equals 12. 7 plus 5 equals 12. 12 take away 5 equals 7. And we start recording that we're seeing a lot of these same things happen. We are discovering fact families within our lessons instead of me just telling them this plus this equals that. Okay, now move the numbers around and do subtraction. Their understanding of this relationship between addition and subtraction will be better because they found it themselves and they proved it themselves, and it's something that they noticed over and over and over again, so they're able to move it to a generalization that it will always work, and this generalization will carry over later when they move on to multiplication and division.